Hi everyone, this is the video for the next part of the notes for Quadratics 2. So we've got example 3 here, having looked at how to solve quadratics when we have two brackets equal to 0. So this is going to be questions, and the past paper questions will be the same, where we have questions in context, and we complete these exactly as before. We just sometimes have to first create the equations to solve, and then, as it says there, discard any negative answers. Okay, so a rectangle has sides x plus 7 and x minus 1. We want to find the value of x given that the rectangle has an area of 48 centimetres squared. Now, a couple of things we need to know to complete this question. We need to know that the area of a rectangle is the same as the length times the breadth. In addition, we need to know that if the area is something, length times breadth, and we are given also an area for the rectangle, then those two things have to be equal to one another. So I'm going to write that round the other way. Length times breadth equals area. The length is x plus 7, and the breadth is x minus 1, and the area is 48. So I can create that equation. Once doing that equation, I can then apply the same method as I did up here for example J, which I've now rubbed out, what you can see in the video for part 1 of these notes. So I multiply out the two brackets on the left hand side, giving x squared plus 6x minus 7. That equals 48. I then have to take the 48 away from both sides to leave x squared plus 6x minus, so we've got minus 7, take away another 48, we will get minus 55 equal to 0. From here then we can do what we did previously with the last example. So we've got a trinomial, which means we factorise using the ABC method. So A is 1, B is 6, and C is negative 55. A times C then is negative 55. I need two numbers that multiply to give negative 55 and add to give me the 6 in the middle. So 11 and 5 are the common ones for 55. They will combine to give you positive 6 if you use negative 5 and positive 11. Okay, those two times together will give you negative 55, so that's fine. And also negative 5 plus 11 will give you the positive 6 that we're after. So let's try and put these into context then. So x squared will make that minus 5x plus 11x minus 55. We then take out a common factor as before of the first two terms, which is x. That leaves x minus 5. Keep the plus. Take out a common factor of 11, which leaves x minus 5. The two brackets then are x minus 5 and x plus 11. That has to equal 0. So either x minus 5 equals 0, which would mean x is 5, or x plus 11 equals 0, which would mean x is negative 11. Now, normally that would be us completely done if this was a regular question. Since we have a context question, we have to then refer back to our previous example. So we are told these two expressions for the lengths of the rectangle. If I was to say that x was 5, then it would be 5 plus 7, so that length would be 12. It would be 5 minus 1, so that length would be 4. Okay, that's possible. So 5 is definitely possible for x. The other answer for x that I got down the bottom of this question was negative 11. So if I was to use negative 11, it would be negative 11 plus 7, which is negative 4, and negative 11 minus 1, which is negative 12. Now, that doesn't make sense. we can't have a negative length, okay? A length is a measurement, is how long something is. It can't possibly be a negative number. Okay, so that means that the last thing we have to do is to say that x equals 5 is the final answer, and we discard x equals negative 11. Okay, so that is no longer a possible answer. Now, the thing with these questions in context is that we have to discard one of the values if it's not possible. So if you don't write discard x equals negative 11, then you won't end up with full marks for these questions. Okay. Additionally, thinking about as we're heading into higher as well, this becomes more important to make sure you discard non-possible answers. Okay. So the past paper questions here. This one looks quite tricky, but actually it's not too bad. Okay, so it looks like a functions question because we've got f of x and g of x. But actually what we're told is this term on the top is f of x, this term on the bottom is g of x, f of x equals g of x. So from all of that, I can say x squared plus 2x minus 1, which was f of x, is equal to 5x plus 3. And that's me just replaced f of x on the left hand side of the equals and g of x on the right hand side of the equals. Now what I need to do is rearrange so that I've got 0 on the right hand side. So take away 5x from both sides. This is where you've got to really know your algebra terms. So x's can only be taken away from actual x's, not x squared. 2x take away 5x is minus 3x. I'm also in the same motion going to take away 3 as well. So take away 3 from that minus 1, and that will give me minus 4, and that's all equal to 0. A, B and C again, and then A times C. So A is 1, B is negative 3, C is negative 4, A times C is negative 4. I need two numbers that multiply to give negative 4, so I'm probably going to use 4 and 1, because they'll combine to give 3. It has to be positive 1 and negative 4, because 1 take away 4 gives the negative 3 that I'm after. So we'll make that x squared minus 4x plus 1x minus 4. Common factor of the first two terms leaves you with x bracket x minus 4 plus, and you don't need to take out a common factor, just leave that as 1, and that's then x minus 4. Two brackets will become x minus 4 and x plus 1 equal to 0. So x minus 4 equals 0, x equals 4, x plus 1 equals 0, x equals negative 1. Now, since this question's not in context, there's no story or shape or anything around it, then we can have those two values as are possible for x. Question 2 is quite a tricky one, okay? But we'll just take it step by step. It is doable, it just is very tricky. So, question A, we want an expression for the area of the rectangle. So before I do anything, I'm going to put brackets around those. And I'm going to say the area of the rectangle is length times breadth. So that is 2x plus 1 times x plus 8. And you'll see that's why I've put the brackets around it. Now that gets you your first mark. You don't have to bother doing anything with that. However, you are going to have to use the expanded form of this in question B. So I'm going to expand it first. Do that bit now so I've got it ready for me for question B. So when I expand this, it's 2x squared plus 16x plus x plus 8, which gives me 2x squared plus 17x plus 8. So that's your expression for the area of the rectangle that we're going to then use to help us complete question B. Now, question B says that given the area of the rectangle is equal to the area of the triangle, show that that expression comes out at the end. So, I've got an expression for the area of the rectangle. That's what I calculated in part A. So let's find an expression for the area of the triangle. Area of a triangle is half base times height. So a half times 2 bracket x plus 5 times 3x. Normally our 3x comes out the front, but I've done it this way for a reason. So this is going to be a half times 2 times this bracket times 3x. Now a half times 2 is the same as just 1. A half of 2 is just 1. So that becomes 3x bracket x plus 5. Multiplying that out gives me 3x squared plus 15x. Now we're told that those two areas are equal to one another, which means this area or this expression is equal to this area here, so that expression there. Since I've got a larger number of x squareds with the triangle, I'm going to put that on the left hand side. So 3x squared plus 15x, which is the triangle, is equal to 2x squared plus 17x plus 8, which is the rectangle. Now I can take away 2x squared from both sides, leaving x squared plus 15x equals 17x plus 8. I can then take away 17x from both sides, giving x squared minus 2x equals 8. I can then take away 8 from both sides, that shouldn't be 12, it should be 2. I can take away 8 from both sides, giving x squared minus 2x minus 8 equals 0. That is exactly as it was required to be, therefore I've answered the question. Okay, now that's very, very tricky, that middle bit there. It is very kind of, requires a lot of previous knowledge as well, but once we get to that stage, that is us then done the question. Okay, we know what we're trying to get to, which is quite handy. Question C asks us to find algebraically the length and breadth of the rectangle. The length and breadth of the rectangle include letters x, which I don't know a value for yet, which means I have to use this expression, x squared minus 2x minus 8 equals 0, to find values of x, which I could use to find the lengths of the rectangle. I can also use that expression from question B, so without even getting the 3 marks for question B, I could have used the formula or the equation x squared minus 2x minus 8 equals 0 without even doing part B. I've got that expression already, so I can use it in part C without having to calculate it in part B. So you can leave out part B and actually just do part C to find the two values of x. Now we use the values A, B and C again. We've got 1, minus 2 and minus 8. A times C is minus 8. The two numbers we use for our values of x have to be, it's going to be 4 and 2, and it's going to be negative 4 and positive 2. So therefore we end up with x squared minus 4x plus 2x minus 8. Take out a common factor of x from the first two, leaves x minus 4. Common factor of 2 from the second two leaves x minus 4. And two brackets are x minus 4 and x plus 2. That's equal to 0. X minus 4 equals 0, so x equals 4. Or x plus 2 equals 0, so x equals negative 2. Now again, since this is in context, we can't have a negative length for the rectangle, so if x was equal to 4, we could do x plus 8, which would be 4 plus 8, which would be 12, that would be okay. 2x plus 1, that would be okay as well. But if x was negative 2, we'd end up with negative 2 plus 8 on the bottom, that would be okay, it's still positive. but we'd end up with 2 times -2, which is -2, plus 1, which is -3. Therefore, we can't have that negative length, and before we go any further, we have to say x is 4, and we discard x equals -2. So if this is in context, you have to remember and write that. Discard x equals -2. Therefore, the length and breadth, so the length was, doesn't matter which one of these you call the length and the breadth, they're both going to end up giving you a couple of answers anyway. I'll call the length x plus 8, which x is 4, so it's 4 plus 8, which is then 12. And the breadth was 2x plus 1 from the diagram, so 2 times 4, which is 8, plus 1, which is 9. Just check if there's any units on those. Centimetres, yep. So set up top there, measurements were in centimetres, so that's our length and breadth. That is probably the most complicated question you will see. Or in fact, one of them, there is one a little later on. But that's one of the most complicated ones you will see with this type of question. Okay. Right, I think we're on to the last past paper question here. So that is looking at questions which are involving a graph that's given to you. Okay, so we're having to put the kind of solving this equation into a context as well. So, write down the coordinates of Q and R. Now, we are given that, so put A down here. We are given that y equals x minus 8 and 2 minus x. Now, we know that from the start of this set of notes that when we calculate the two values of x, what we're actually finding are where it crosses the x-axis. Okay, we're finding the roots. Therefore, if I set these two brackets equal to 0, so I say x minus 8 and 2 minus x is equal to 0, then we'll find out what values are both q and r. So putting those two separately, x minus 8 equals 0, so x has to be 8. 2 minus x equals 0, so x has to be 2. Therefore, the coordinates of q, so q is the first one, 2, 0, and r is the second one, has to be 8, 0. Remember, our coordinates are always x and then y. So the y value is 0, since we're not going up any, we're just going along. So if we're on the x-axis, our coordinates are always x and then 0. Right, so question B, we can find the height of the letter A. The first thing to notice about this diagram is that from the origin line, so from the x-axis down to the bottom of the A, we have a length of 16. So 0 down to -16, which is a total of 16. Okay, what we don't know is the length from the x-axis to the top of the A. The good thing about this is that this point up here is a turning point, x, y. We looked at this during the first section of the quadratics notes when we had to calculate the turning point. Essentially what I want to do is find the value of y, because that will tell me how far up I have gone to get to the top of the letter A. Now, the value of x can be used to find the value of y, and the value of x is directly in the middle of the point Q and R. Okay, so the first thing I need to do for part B of this question is to find the midpoint of Q and R. To do that, okay, we think of what number lies in the middle of 2 and 8. Now we can find that by saying, adding those two numbers together and then dividing it by 2. That's probably the easiest way to do it if you can't spot what number it has to be straight off the bat. So take your two numbers and divide by 2. 2 plus 8 is 10, divided by 2 is 5. Therefore, x equals 5. I'm looking for a point x, y. X equals 5, and y, all the way up at the top of this example, was that expression there, x minus 8, 2 minus x. So, y equals x minus 8, 2 minus x. X is equal to 5, so I put x and 5 in place of x. That's a 5, not an x anymore. 5. That becomes then 5 take away 8, which is negative 3, times 2 take away 5, which is also negative 3. So y is equal to 9. Therefore, the point up here, xy, which I've put in green there, has to be the point 5, 9. Therefore, that point there is at 9, and this distance is a distance of 9. From the bottom to the x-axis is 16. From the x-axis to the top is 9. Therefore, the height, to finish off question B, the height of the A is 16 plus 9, or 25. Okay, do we have any units? No, so just 25. 25, whatever units they're going to measure it in. That question again is quite tricky, but it's using our solving equations thing in there for solving quadratics. Okay, so that's why it's contained within this section of the notes. The next thing we're going to do is look at the quadratic formula. I'm going to give you another separate video for this again, so it'll be part 3 that you will find these questions in. Okay.